Hello everyone. So till now we have finished two chapters in physics part of class 9. So today we will be continuing with the third portion, means the third chapter, and the chapter name is Gravitation. Chapter number 10, Gravitation. So in this chapter we'll basically learn about the force of attraction between in our solar system, which is the very most important thing, that is gravitation. Gravitation is very essential for us because it is the main thing or the basic thing which is responsible for our survival, because if there was no gravitational field on the earth, we would have been flying in the universe. We would have gone in the flying in the universe and we would have died. So this gravitation part is not just limited only to our earth. It is the basic driving mechanism or the driving force of our universe, of our solar system. The planets move around the sun because of the gravitational pull between the sun and the planets, and due to which everything is going in a proper way. Means all the planets are moving in their respected directions, in their respected orbits. So the idea or the main basic theory of gravitation was given by Sir Isaac Newton. So it was a very popular story, as when one day Isaac Newton was sitting under a tree, under an apple tree, and one apple fell on his head. So at that time, basically it was a common thing. If you are sitting somewhere under a tree and if a leaf falls down, we basically don't consider it or we don't think about it. But that person, Isaac Newton, thought that why did the apple fall onto my head? Why did it go upward somewhere else? So he took the apple and, like, instead of us like eating out the apple, he tried it one more time. He took the apple, threw it up, and again the apple came down. So at that time he noticed everything which is in some upper height or in some height, if it is left from there, if it breaks from there or it is detached from there, the object or the thing comes down every time. It does not matter what type of thing it is. It can be a stone, it can be an apple, it can be a leaf, or even it can be a feather. Everything which is in a certain height comes close or falls onto the ground. And from there he gave the idea that something might be there on our earth or inside the ground which is pulling the things down. Otherwise, why would the things fall down or come down? It should go up, like as the apple is on the tree, hanging from the tree. For example, the apple is hanging like this. After it is detached from the tree, it should go up. Why is it coming down? Means something is, or some force might be there which is pulling the thing or the object down to the surface or to the earth or to the lower surface or towards the ground. So after this experiment or after this conclusion, Isaac Newton further researched on this topic, further gathered some more information, some more knowledge, and finally he told that in our solar system also this force exists, and this force is responsible for all the planets moving around the sun, constituting our solar system. So from the gravitation, he gave three laws. Means he gave the universal law of gravitation, which helps to govern or which helps to or which conducts the movement of any other thing around our planet or in our solar system. That was known as the universal law of gravitation. So according to this law, if there are two objects, one object I have just taken circular, it's easy to understand, and another object which is also circular in shape. So what happens? This is object A, this is object B. So according to this law, as per the law, both the objects A and B will be having some force of attraction, means pulling each other. Object A is a solid object, it is matter, so we know matter has a mass. So in the center. So this will also have some mass, and object B will also have some mass. And this object A will put some gravitational force, or will put some force pulling object B towards it, and similarly object B will also be pulling object A towards it. And this force is known as the force of attraction between two bodies. So according to the universal law of gravitation, the force between two objects is directly proportional to their mass, to the product of their mass, and inversely proportional to the square of the distance between them. So I'm writing it here. So according to this law, the force between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. You can pause the video and write it down. So as per the law, we will follow. So according to law, as said, and rubbing it down and rubbing this part. Okay, just look here. So as I told, there are two bodies A and B, and both the bodies will be having some mass, will be having some weight. So as body A I have drawn bigger, so let it be having mass capital M, and as body B was small, let it be mass as small. So according to this law, and from here I am continuing here in the upper portion, don't get confused. So according to the law, as told, the force is proportional to the square or to the product of the mass, means capital M into small m. And also it is said the force is inversely proportional to the square of the distance. Now A and B are little bit or some distance apart from them, and if we consider this distance as B, just B, so it will be 1 by B square. So finally, from here, combining this, we get force proportional to M, or we can write M into M divided by B square. Okay, so I'm just writing it down. This is what you might have written. So from here we can keep like number 1, number 2. So from 1 and 2 we can get F proportional to M into M by B square. So this is the basic representation or the numerical representation formulation of the law of gravitation, means universal law of gravitation. Now this is a proportional symbol. This is a proportional symbol, and we don't know, or we don't have a proper tool or means to solve or to do any numerical calculations using this symbol. So this is a proportional. So to remove that proportional, we use here a fixed value, that is G, and to remove this one, okay, so this is M by B square. So this G is the universal gravitational constant, means this G the G is known as universal gravitational constant, and this G has a fixed value, means this G will yield us a fixed number which does not changes. Means if you are finding the force between any two planets, this G will be same. If you are finding the force between Earth and the Sun, this value of G will be same. So it does not changes where you are on Earth or you are on Mars or any other planet. Basically you cannot go. So just for understanding. So this is universal gravitational constant, and this G here is known as proportionality constant, means it helps us to remove that proportional symbol and make it equal. Constant. This is our proportionality constant. So the basically constant always means a fixed value. So here this proportionally constant helps us to remove this proportional symbol. Now we want to know what is the value of G. This is our basic formula for this chapter, the force between any two bodies. And now if we rearrange this formula, we can get G equal to F B square by M into M, this one. And after taking some specific values, or after taking the fixed values between the force, distance and this mass of the objects, this value was solved by Henry Candevish, and using some sensitive balance. Then he found the value of G. He found the value of G equal to 6.67 into 10 to the power 11 minus 11 Newton Newton meter square per kg square. This is the value of G, which you have to remember. This value will be used using some numerical problems of this chapter. So you can put it down, and in the definition you can pause the video and write it down. This was only for today. Thank you.